Hello everyone. Today's lecture will be on IoT and M2M model. That is, what is IoT and machine-to-machine model? What is the difference between them? How they are implemented? What are their protocol structure, etc. Machine-to-machine model (M2M model). M2M model refers to the networking of machines or devices. It is the network of devices for the purpose of remote monitoring and controlling the data exchange. It is nothing but these various networks connected, and they are able to monitor any parameter and control, and data exchange is possible between them. An M2M area network comprises of machines which are having M2M nodes which have embedded hardware modules for sensing, actuation and communication purpose. There are various communication protocols that can be used for M2M local area networks such as ZigBee, Bluetooth, M-Bus, Modbus, Wireless M-Bus, Powerline PLC, Powerline Communication, IEEE 802.115.4, etc. These are various communication protocols through which the communication between these hardware modules of embedded devices take place in M2M model. The communication network provides connectivity to remote M2M area networks. The communication network can use either wired or wireless networks. Like it is also called, it is used IP based or non-IP based. The communication network can either use wired or wireless networks. While the M2M area network use proprietary or non-IP based communication protocols. The communication network uses IP-based networks. So the M2M area network use non-IP-based communication protocols, but the communication network uses IP-based protocols. Next topic is M2M gateway. Since non-IP based protocols are used within M2M area networks, these are non-IP based protocols, so the M2M nodes within one network cannot communicate with other nodes in an external networks. So to enable the communication between remote M2M networks, the M2M gateways are come into picture and they are used for that purpose. Like in the following diagram, you are seeing that M2M nodes are placed in an internal network and they are communicating with the help of various uh, Bluetooth, ZigBee, uh, Z-Wave, Modbus, etc. With the help of communicating with the help of these protocols, and between their M2M gateways, and there is an external network, external area, remote area, and in between there is M2M gateway. Now we will study about the various differences between IoT and M2M models. The difference will be based on our communication protocols and the machines used in M2M and things in IoT. First one is communication protocols. The M2M and IoT devices differ in how the communication between the machines or device happens. So M2M uses either proprietary or non-IP based communication protocols for communication within the M2M area networks. Now the second difference is machines in M2M versus things in IoT. The things in IoT refers to the physical objects that have unique identifiers and can sense and communicate with external environment or their internal physical states. But in M2M systems, in contrast to IoT, typically have homogeneous machines within an M2M area network. So these are the differences between IoT and M2M. Difference on the basis of hardware versus software emphasis. While the emphasis on M2M is more on hardware with embedded modules, the emphasis of IoT is more on software. Data collection and analysis. While the M2M data is collected in point solutions and often in on-premises storage infrastructure is provided. But in contrast to M2M, the data in IoT is collected in the cloud, which can be public, private or hybrid cloud. Second difference point is on the basis of applications. The M2M data is collected in point solutions and can be accessed by on-premises applications such as diagnosis applications, service management applications, and on-premises enterprise applications. But in case of IoT, the data is collected in the cloud and can be accessed by cloud applications having analytics applications, enterprise applications, remote diagnosis, and various managed applications, etc. So in this slide, there is like a model. Like we are having TCP/IP model. This is the communication model for in IoT and M2M model. First one is for IoT and second one is for M2M. There is one application layer having various protocols, HTTP, WebSockets, MQTT, DDS, MQP. Then the transport layer, and they all get connected to the application layer and transport layer. But in M2M, the first one it is most hardware based, so that's why network layer is provided on the first and link layer provided on in first half, and they are get connected to the network layer and link layer only. So M2M is basically the hardware based and mostly the hardware based, and IoT is the base, so the is software based. And the various network and link layer protocols like Wi-Fi, Max, WiMAX, cellular, Ethernet. These are all protocols and the various guidelines which are used to implement M2M devices and IoT devices. Now we will study about SDN. SDN nothing but a software defined networking. It is a networking architecture that separates the control plane from the data plane and centralizes the network controller. It basically separates the control plane from data plane and centralizes the network controller. Software based controllers maintain a unified view of the network and make configuration, management and provisioning simpler. Software in this SDN, the underlying structure in SDN uses simple packet forwarding hardware as opposed to special hardware in conventional networks. In SDN, there is one application layer having various network application having, and in between there is a NOS network operating system, and then they are connected to infrastructure layer having simple packet forwarding hardware. Simple packet forwarding hardware are connected all around. This is the architecture for software defined networking, which basically separates the control plane from the data plane and centralizes the network controller. Now we will study about the key elements of SDN, software defined networking. What are the key elements of SDN? First one is centralized network controller. With decoupled control and data planes and centralized network controller, the network administrator can rapidly configure the network. Because of the centralized system, the network administrators can rapidly configure the network in an easier manner. Programmable open APIs. The SDN architecture supports programmable open APIs for interface between SDN communication application and control layers. That is, application programming interfaces are used in programmable open APIs. Third one is standard communication interface, OpenFlow. SDN architecture uses a standard communication interface between the control and infrastructure layers. Second one is OpenFlow, which is defined by the Open Networking Foundation, that is the broadly accepted SDN protocol for the southbound interface. Now this is NFV, Network Function Virtualization. It is a technology that leverages virtualization to consolidate the heterogeneous network devices into industry standard high volume servers, switches and storage. NFV is complementary to SDN, as NFV can provide the infrastructure on which the SDN can run. It is the diagram for NFV architecture. First one is virtual network functions, VNFs, and under it, beneath it, is the NFV infrastructure, which comprises of virtual compute, virtual network, virtual storage, and in between there is a virtualization layer, then compute network and storage. And there is a NFV management and orchestration at the same time, computing and enabling the infrastructure on which the SDN can run. Now, what are the key elements on NFV? Virtualized network function. VNF is the software implementation of a network function which is capable of running over the NFV infrastructure NFVI. NFV infrastructure NFVI includes compute network and storage resources that are virtualized and are placed under and above of the virtualization layer. Now there comes another resource which is NFV management and orchestration. NFV management and orchestration focuses on all virtualization specific management tasks and covers. It is like a manager of all the tasks and covers the orchestration and lifecycle management of physical or software resources that support the infrastructure virtualization and lifecycle management of VNFs. This is an example on NFV. NFV use case. NFV can be used to virtualize the home gateway. NFV infrastructure in the cloud hosts a virtualized home gateway. The virtualized gateway provides private IP addresses to the devices in the home. The virtualized gateway also connects to network services such as voice over internet protocol and IPTV. Like you can see in the diagram, there is a home network, UIP phone, IPTV connected to the wireless access point like router, and these all devices are connected like tablets, lights, single board computer, smart machine, smart washer, smart refrigerator. These are all connected to the wireless access point layer 2 device. And like in this, the public network having internet, IPTV, VoIP, and virtualized home gateway and NFV infrastructure through which the connect various network services such as VoIP and IPTV.